like the format of, oh wait, there we go. Okay.
Yeah.
This is just about like the format of the like last time I know we had like some work on like composition of functions. Is
Yes.
that something that'll also be on the quiz?
Yes.
Like composition stuff? Okay. And
Yes.
it's like just like the same difficulty like we've been doing before.
Yes.
Okay. Okay. Got it. Okay. I'm just gonna say mute, but I'm just gonna wait to see if other people ask
Okay.
later.
Okay. And yeah, and I'm probably going to answer or tell people it when and if people pop on that I first want to answer any questions related to stuff that would be on the quiz if there are any.
Yeah.
And then after that, I'm happy to answer any transformation questions. But
Okay. Cool.
E-Block hasn't had, they're a class behind because I see them tomorrow morning. So I could
Right.
see them having a ton of transformation questions that I'll go over in their class tomorrow anyway. So
Yeah.
I'm going to try to hold those guys off if they come on.
Okay, cool.
Yeah, we'll wait and see if anyone comes on. Hi, Annie.
Hi.
Hi, Aria's on too, and she's just waiting to see if anyone has questions. And so if you have questions, feel free to begin, or you can just hang and wait and see if other people have questions. But if you have questions, feel free to ask me.
Yeah, for sure. I think for now I'm just gonna wait and see.
Okay. Okay. Yeah, I'm gonna give it a few minutes, and then if no one pops on, maybe I'll just throw out a domain and range problem, and you guys can try that, and then we can go through it.
All right, sure.
Okay. Hello, Asher. Did not connect. Let's see. Asher, you there? Oh, there you are. Hello, Asher.
Hello.
Hello. Do you realize your name shows up at Ash RL?
Oh, I typed it in pretty quickly.
I didn't know if that was purposeful.
Yeah.
If you now are going by Ash.
Yeah,
So if you have a question, feel free to ask. If you're just hanging out, that's fine too. But I always like to give, if you're on first, you get first dibs if you wanted to ask something.
Yeah, nothing for now, but I'm just gonna do the similar work and I'll probably have a question.
Okay.
Yeah.
All right. So for year 3 on, how about I throw out a composition problem and you guys can see if you kind of, it's basically, dealing with domain and range. So let me I'll make something up right now. Let's see if I can connect my iPad here. It worked before, so let's hope it works now. Okay. Can you guys see that?
Yeah.
Yeah.
Fabulous. Okay. So let's say let f of x equal, let's do square root of x plus 1, and g of x is 1 over, let's do minus square root of x plus 1. Actually, I'm going to make it even more challenging. Let's make this -3. Okay, so let's do the first question. Think if I said find f of g of x, and then the second question will be find, actually, no, let's not do f. Let's do the other way around, g of f of x. Find g of f of x. Yeah, let's do that way. I wrote this wrong. Sorry, I'm making this up as I go. So sorry about the edits. Okay, is that what I want it to be? G of, yeah, okay, let's do that. And then find the domain and range of that. Keep on saying f of g of f of x. Okay, so if that were a problem, so this is just going back not only to domain and range, but also thinking about a composition. So kind of take a couple minutes to see what you could do with that, and then we can go over that. Hi, Malia.
Hi.
Hi. So I just threw out a problem because no one at this moment had a specific question. So it was like a combination of a composition and domain and range problem. But feel free, if you have something that you want to ask me, you can do that too.
Okay, got it. Sounds good. I think I'm good for now, but I might have like a couple.
Yeah, so try this. And then after we go over this, we can do an inverse problem if people want to. You guys need more time? Or do you want me to go over it?
I just need like 1 more minute, but I'm almost there.
Yeah. Yeah.
Yeah, like a minute more.
Okay, let's give it till 8:10. So I'll give you guys 2 more minutes and then we'll see how we did.
All right.
Okay, so let's look at this. And so for the first step, I just find it helpful to write, okay, into the g function, I'm putting the square root of x plus 1, which just means wherever there's an x in the g function, I'm putting the square root of x plus 1. And so we would have something like that. Everyone get that?
Yeah, I got that.
Yeah.
Fabulous. Okay, so now here's the key with, although it doesn't come into play that much here. But remember when we talk about the domain, what matters with the domain of compositions is the domain of the inner piece, the inner function, because it has to pass through that first, and the domain of the end result. So if I think I'm putting in the square root of x plus 1, that's what I did to get this new equation. Right away, that limits to the domain to what? Because it's first passing through that inner function. So right away, what does it restrict to?
Less than -1.
Yeah, it has to be greater than or equal to -1, right? Because you can't take a square root of a negative. And truth be told, in this case, it would show up. But sometimes, like say the x in the g of x had been squared, that won't necessarily show up when you do the composition, when you do the end result. But you have to make note of the fact that it has to go through that initial function first. Okay, so then I go to my composition that I already found. I already know the fact that x has to be greater than or equal to -1. What's the other thing in the domain I have to worry about?
The denominator can't equal 0.
Yeah, so 2 minus the square root of x plus 1, exactly, cannot be 0. So 2 cannot be the square root of x plus 1, which when I square both sides, what do I get that x can't be?
3.
3. Okay, so then we just put those two things together. So starting off greater than or equal to -1, I'm good until I get to 3, and then 3 to infinity. So again, just keep in mind, it didn't come into play here, but always consider the domain of the inner function because it has to pass that as well. Okay, so now the range. Everyone's favorite is range. Thinking about what's varying is the denominator. So what is the range of just the square root of x plus 1? What values could that achieve? Actually, let's just think of the denominator. I'm not even going to put it in the fraction form yet. Let's just think of if I just had 2 minus the square root of x plus 1. It'd be 2 minus, what's the range of square root of x plus 1?
-1 infinity.
You're thinking domain, the output.
Right.
So what the output coming out of the square root, what's the smallest that I could get coming out of that square root?
0.
Yeah, so it's 0 to infinity. And so thinking about the range of the denominator, if I do 2 minus that range, it would be -infinity to 2. So if I just had the denominator, that would be the range, but it's at the bottom of a fraction. So putting it at the bottom of a fraction, what can it definitely not be? What can I divide by in a fraction? So I'm not just going to write -infinity to 2 because what couldn't I have? I can't have 0, right? So I could not divide by 0. So it's important to put that down for your analysis because otherwise people have a tendency to mess up the range. So again, what I first did was the range of the denominator, just looking at it by itself, noticing it goes -infinity to 2. And then because it's in, now I'm putting it in the fraction, and because it's in the denominator, I can't have 0 because I can't divide by 0. Okay, so now let's just work through piece by piece. And what I mean by that is you're going to do -3 divided by -infinity. And what does that get really close to?
0.
0 from the positive side or negative side?
Positive.
Positive, yeah, negative by a negative. So I know I've got 0 from the positive side. -3 over a tiny negative. What's going to happen there?
Infinity.
Yeah, a negative over negative, definitely positive, and a negative number, a number over something really tiny is either infinity or -infinity. In this case, because it's a negative over a negative, it'll be positive infinity. Great. -3 over something close to 0 from the positive side. What's that going to get us towards? Definitely something negative because a negative over a positive. So
Negative.
Go ahead.
Negative.
Yeah, negative infinity, right. Remember, when it's super tiny in the denominator, it has to either explode in a positive way or negative way. All right, last one. -3/2 is just what it is, -3/2 with a bracket. And that's your range of that problem. How was that for you guys? Is that
I
okay?
did the I did the domain of the function of the like 2 minus square root of x plus 1 instead of the range.
Yeah, me too.
Oh,
Like
gotcha.
did all the steps, or I did the steps right, but then it like
Yeah.
Okay. Yeah. So important to distinguish between the two. Okay. Yes. So make sure you think of output versus the input. Yeah. So separate. Okay. How about, what do you guys think about trying an inverse problem? Would that be helpful?
Yeah.
Okay. All right. Let's see. I'm gonna do, actually, I'll add a page. Oh, no. I'll just move down. Okay. To a new page here. Okay. So let's do find the inverse. And first I'm going to write one down and you guys can work on that while I think of another. Equals. Squared. Okay, so try that one, and I'm going to think of another while you guys try that. Okay, that's the second one. You guys need another minute or so?
Yeah, just a little bit.
Okay. No problem. All right, let's see how we did. Okay, so notice both of these have restrictions, which means there's something we're going to have to think about as we go through this. So how I start is I think, what am I doing to X to get the function I have here? And that would be adding 3, squaring it, multiplying by -1, and then adding 4. Do you guys agree with that?
Yeah.
Okay. All right, so now to undo this, I'm going to subtract. So I'm going to start with X. I'm going to work backwards and do the opposite. So subtract 4. Instead of multiplying by -1, I divide it by -1. And I would say at this step, because we don't want to deal with complex fractions, and when we can make things simpler, we want to do so. So if I divide by -1, I've got 4 minus X. Just makes it look cleaner. Okay, and now the key to remembering that the opposite of squaring something is square rooting it, but you can either do the positive square root or the negative square root. And what do I have to do in this case?
Negative.
Yeah, and the reason is the restriction always is going to tell you which one to do. In this case, because the domain of the original is basically only negative infinity to -3, that better be the range of my inverse. So that means the only way that's going to happen is if I have a negative square root. So I'll just say y to the -1 for my inverse is going to be, so I've got the negative square root of 4 minus X. And then instead of adding 3, I'm going to subtract 3. And then just eyeballing this, does it make sense that the range of this is -infinity to -3? It absolutely does. Yes. So that is fine. And the second thing I'm also going to eyeball is make sure that I don't have anything squared or to an even power here. So I don't need a further restriction, which I don't. So the inverse itself doesn't need a restriction, just the original in this case. Is that okay?
Wait, can you go over like why the square root could either be positive or negative again?
Yeah, because think about the opposite of squaring something. So if I have something squared equals a number, then that means that something is either the positive or the negative square root. So for example, x squared equaling 4, if I go to solve that, it's either positive or -2, or positive or negative the square root of 4. So whenever you think of the opposite of squaring something, it could be the positive square root of it or the negative square root of it.
Okay, that makes more sense.
Yeah, so the opposite of squaring is the square root, but it also could be the negative square root because something negative squared becomes positive. So that's just an important piece to keep in mind. So the fact that the opposite of squaring is either the positive or negative square root of something. And I always think about when I'm solving for something squared, I'm either doing the positive or negative square root to undo that square. Okay, so that's where the restriction comes into play. And that's where you have to think about the restriction. Okay, so part B, I'm going to square X. So that should clue you into, at some point I'm going to have to do the opposite of that and think about which it is. Then I'm going to multiply it by -1, add 16, so plus 16. Then I'm going to take the square root. And then the last thing I do is divide by 2. Okay, so the first thing I'm going to do to X is multiply by 2. So I've got 2X. What's the opposite of square rooting?
Squaring.
Squaring. So when I square that whole thing, I'm going to just make it simpler and say 4x squared. Okay, instead of plus 16, it's going to be minus 16. And then dividing by -1, again, to make it a little bit cleaner, I'm going to say that this is 16 minus 4x squared, just switching the signs since I'm dividing by -1. And now when I'm doing the opposite of squaring, do I want to do the positive square root or the negative square root here?
Negative?
Yeah, again, the range is mostly negatives here. So I better have a negative in front of the square root. Otherwise, my range is mostly going to be positives. So I'm going to have negative the square root of 16 minus 4x squared. And you can leave it like this, or some people may notice, what could I factor out of this square root? Again, 16. To be safe. Not quite 16. What do they both have in common?
4.
4. So if I like bring a 4, again, I'm still in the square root. Again, no need to do this if you feel like you're going to mess it up, but I just want to show you that it could be done. And now when you have multiplication in a square root, you can take out anything that's a perfect square here. And so I could factor out the 4 as 2. So it also could be written like this. Same thing. So, but if you want to leave it as original and you're afraid you're going to mess up simplifying, just leave it as this one. But we're not done, because what do you notice about the inverse that we just found? It has something squared. And is that problematic? Anything that has any function that involves x being squared, what do we know about it?
Oh, so it'll all be positive then?
Well, it just means it's not invertible.
Yeah,
so
it's
that,
not invertible.
Yeah, so that's a problem. So because we're finding an inverse and they both should be inverses of each other. So that means I actually need a restriction on it. And how I find, this is like the warm-up we did in class that one day, and how I find what the restriction is, well, it's always a domain restriction. So what would I need to do to figure out what the domain restriction is for this inverse? How does the domain of the inverse relate to the original?
Oh, it's the range.
The range, yeah. So I better find the range, because they should totally flip. And if I left it like this, not so much. So let's find the range of the original function. So to do that, I think about, all right, can 0 come out of that square root of 16 minus x squared? This is the range of the original. 16 minus x squared, could that ever be 0?
Yeah, right.
Yeah, if I put a -4, I'm going to get 16 minus 16. So yes, so 0 would be the low of the top. Does it go off towards infinity? So it's going to be no, because it's always 16 minus something that's 0 or positive. So what's the highest that can come out of that square root?
4.
4. Yeah, exactly. 16 minus 0 is going to be the highest. So 0 to 4. And then, of course, I have divided by 2. So the range of the original is just 0 to 2. And so that needs to be my restriction. So I'm going to say my inverse, and it doesn't matter which form you put it in of any of these three. I'm just going to say for x between 0 and 2. So again, just noticing, and I purposely picked these two because notice the first one, the process was nearly identical. Like I had to think about, is it the positive or is it the negative square root when I find the inverse? But then when I looked at my inverse, the inverse in the first one, there doesn't involve any square. It's 1-to-1, so I don't have to worry about any restriction. But unfortunately, with the second one, the inverse also contained a quadratic term, meaning something squared, which resulted in this being not 1-to-1. So I needed to put a restriction on it. And what is that restriction? It's always the range of the original, because domain and range totally flip. Thoughts? Second one was harder, right?
Can you go over like, maybe you were just talking about this, but like what we should look for, like to make sure, like in the last one, there was a squared value.
Yeah.
So
what you should look for if you have found an inverse to see if you actually need to add a restriction also to that inverse, like we just did, is if the only variable you have is raised to an even exponent, or in an absolute value. Because that's the case where those are not 1-to-1. So they cannot stand alone at either as original functions or as inverses, if we're talking about inverses. So again, either the variable is raised to an even exponent or the variable is in an absolute value, because that means it's not 1-to-1. It means negatives and positives are both going to give the same output, which is exactly what not being 1-to-1 means.
So if you had a function with like the absolute value, like would you need to have the domain restrictions like in the first place, or would you not even be able to invert it?
If I just had an absolute value without a domain restriction, you wouldn't be able to invert it. No.
Okay.
And in fact, I'm not going to I'm just telling you absolute value. We haven't talked about, we can't do that yet. That's next unit. We'll talk more about absolute value because we have to write absolute values as piecewise functions, which we haven't even done yet. So you're not going to get an absolute value one. But Andy, I just wanted to answer your question that could be the case, but you're not going to get that. So for now, you're just looking for variables raised to an even exponent.
okay.
Yeah, so those are like the main things to think about when you're talking about domain and range, compositions, inverse type stuff. Do you guys have any other questions?
I think I'm good.
Okay, well, I'm around tomorrow for sure. Some of you are in A block. Wait, are all of you in A block? No. But as you saw during tutorial, at least most of tutorial, I'm doing a peer tutor training. And so you guys are welcome if you want to be peer tutors too. And you're welcome to hang just to see in case you decide, and in case I have a break and you want to ask me a question. But I just wanted to let you know that's going to be happening tomorrow in my room during tutorial. But I'm around the rest of the day if people have questions. And you can always email me too if something comes up. Okay? All right. Thank you guys. Have a good rest of the night.
Thank you.
Thank you.
Bye.